-2, 7 pi over 6. So that's to the left 2. We're rotating clockwise because it's a negative. 7, no, it's positive, excuse me. 7 pi over 6. So that's 7 pi over 6 is pi plus another one. So put me right there. Is that right? To the left 2, rotate 7 pi over 6 counterclockwise. So is the A point get me to the same spot? That would be left 2, rotate clockwise because the angle is negative 5 pi over 6. That one get me to the same spot? Yes. How about B? -2, so that would be to the left 2, rotate clockwise pi over 6. No. How about C? To the right 2, rotate clockwise pi over 6. No. How about D? To the right 2, rotate counterclockwise pi over 6. Yes. So A and D. Example 3. Let's graph the point. -6, 3 pi. -6, 3 pi would be to the left 6. 1, 2, 3, 4, 5 per 10. You got to go out 1. Your circle only has a radius of 5, and then you're going to go counterclockwise 3 pi. So you'll go all the way around. That's 2 pi. And then you go another one around, so that's over here. So you're kind of off the graph, but we're right here. Does that make sense? So if you go to the left 6 and you rotate counterclockwise 3 pi, that's where you end up. So is A, does that get me, oh, dadgummit, where'd my graph go? Doodly squat. I have to start all over. Alright, so we're on number 3. Oh, what am I doing? Having a come apart. Stay. Alright, so we're here. Is 6, 2 pi get us to the same spot? To the right 6, rotate counterclockwise 2 pi, yes? Yes. To the right 6, rotate clockwise negative pi? Yes. Heard a yes, I heard a no. No? How about -6 pi? How about -6, -2 pi? Just A and C. Does everybody get those? Alright, so you have a little section on your homework once you graph the polar points, and they're going to ask you to do things like example 1, 2, and 3. Alright, next set of directions say polar coordinates are given. Find the rectangular coordinates of each point. Polar points are given. Find the rectangular, the x, y point. That's what rectangular means. They're giving you polar, which is r theta, and they're asking you to find rectangular. So just kind of make sure that you know what you have. Your 6 represents your radius, and your 180 degrees represents your angle, your theta. And then I think I've written on your notes that r is equal to what? I mean, x is equal to what? Did I write that on your notes before I printed them? Okay, we know that x is always equal to, let me show you why. X over r, I didn't write this part, but I want to show you where it came from. Is x over r not equal to cosine? So if we multiply both sides by r, then x is going to be equal to r cosine of theta. And then is y over r not equal to sine? Y'all with me? Is y over r not equal to sine? Yes, if we multiply both sides by r, we get y is equal to r sine of theta. So that's where those two formulas are coming from that I have already written down for you. Since x divided by r is equal to cosine, and if we solve for x, x will be equal to r times cosine, and y would be equal to r sine of theta. So you're trying to find the rectangular coordinates. That means you're trying to find x, comma, y. So this is fairly easy. It's a little bit easier to go from polar to rectangular than rectangular to polar. So to find your x coordinate, you're actually just going to use r times cosine of theta. So in this problem, your radius is 6, and you're going to be multiplying that by cosine of 180 degrees. So you're going to use your unit circle. What's the cosine value at 180 degrees? Cosine at 180. The x value at 180. -1. So that'd be 6 times -1. So the x value in my rectangular coordinate is going to be -6. Then I'm going to find the y value. I find the y value by doing y equals r times sine of theta. That's going to give me 6 times sine at 180 degrees. What's the sine value at 180 degrees? 0. So 6 times 0 would give me 0. So let me make sure what you're doing here. Okay. So if I were on polar graph paper, and I graph the point 6, 180. That would be to the right 6 and rotate counterclockwise 180. That point in polar form should get me to the same place -6, 0 does in rectangular form. So -6 is your x and 0 is your y. So do y'all agree that those 2 points, one's polar, one's rectangular? Rectangular means x, y. Polar means r, theta. Those 2 points get me to the same location. One is in polar form, the other one is in rectangular form. Alright, example 5, 2 pi over 6. Find the rectangular point that gets us to the same spot that the polar point does. So you're going to do x is equal to r cosine of theta. That's going to be 2 times cosine at pi over 6. That's going to be 2 times what? What's the cosine value at pi over 6? Square root of 3 over 2. 2's will cancel, and so your x coordinate of your rectangular point is going to be square root of 3. Then we've got to find our y coordinate. To find our y coordinate, we always do our radius times the sine of our angle. So that's going to be 2 times the sine at pi over 6. What's the y value at pi over 6? 1/2. And 2 times 1/2 is going to give me 1. So my rectangular coordinate that gets me to the same spot as 2 pi over 6 does is square root of 3, 1. So you can always visually check to the right 2, rotate counterclockwise pi over 6, and then square root of 3 is about 1.7. So if you go to the right about 1.7 and up 1, that gets you to the same place as 2 pi over 6 does. So we'll shorten this up a little bit. To find our x coordinate, number 6, we're going to do -6 times what? Okay, let's stop because 3 pi over 2 is a fairly simple angle. It is on the axis. Does everybody agree with that? Let's see if we can do this one without any work because 3 pi over 2 is on an axis. So can y'all visualize where that point would be? That would be to the left 6. Rotate counterclockwise 3 pi over 2. I think y'all can do that one without any work. What would be the rectangular point for negative 6 comma 3 pi over 2? 0, positive 6. If an angle is on an axis, a lot of times you don't have to do the little formula and work it out, because you can just visualize where that point would be and do the rectangular coordinate for it. So anytime you have an angle that's on your axis, pi over 2, pi, 2 pi, 3 pi over 2, you can do the work if you want to. You'll get 0, 6, but I think you can visualize those. All right, number 7. You need to make sure that your calculator is in what? Radians. So they're giving me an angle here that is in radians. So make sure that you go to your calculator and change it from degrees to radians, because it's probably in degrees. So I couldn't do this one without work. So x is going to equal your radius times your cosine of your angle, which is 4.6 radians. You can just round to the nearest tenth here. (8.3) times cosine of 4.6 radians is negative 0.9. And then to find your y value, you're going to do your radius times sine of 4.6 radians. And that's going to get you your y value, which is also negative. And just round to the nearest tenth. Negative 8.2. So your rectangular coordinate for 8.3 comma 4.6 would be negative 0.9 comma negative 8.2. Now that one's kind of hard to check. We could do it if we had to. We talked about some radians in one of those WebAssign problems. So what quadrant would 4.6 radians be in? The third. All right, any questions about that section? You're changing polar coordinates to rectangular coordinates. You're changing polar coordinates to rectangular coordinates. The next set of directions are going to ask you to take the rectangular coordinate and change it into polar. So let's realize what we have. We're given the rectangular coordinate, so we're given x and y, and we've got to convert that into an r and a theta, which gets me to the same spot. Alright, so we're going to use a couple formulas here. I think I wrote them down for you. We're going to use x squared plus y squared equals r squared. If we know x and y, that's how we're going to find our r. So we're going to start out with x squared plus y squared equals r squared. And that's going to give me 4 plus 4 equals r squared. R squared is going to equal 8. And what's r going to be equal to in a simplified radical? 2 square root of 2. So I know that my radius is 2 square root of 2 when I'm converting from rectangular form to polar form. Now your theta, you're going to find that because you know x and y. You're going to set up a little tangent problem. And you're going to say tangent of theta, we're finding our angle here, is y over x. And my y value is negative 2, and my x value is positive 2. And you can simplify that if you want to. So tangent of theta would be equal to negative 1. Alright, if you want your angle to come out in degrees, you're going to need to pick up your calculator and change your calculator back to degrees. You're also going to need to check to see what quadrant your angle is in. So go back to your rectangular point. What quadrant is 2, negative 2 in? Fourth quadrant. Okay, so our theta has to be in the fourth quadrant. Sometimes we won't get a theta in the fourth quadrant, and we'll have to do a little extra step to that. So we do second tan, negative 1, and what does that give you? 45 degrees?
Negative 45.
Does it give you negative 45? Okay. Is negative 45 degrees in the fourth quadrant?
Yes.
They're not going to want your angle to be negative. So what positive angle is equal to negative 45? 315? What radian measure is that? 7 pi over 4. All right, your directions say your angle has to be in radians. So I would probably go ahead and change my calculator to degrees. Now this one we could have figured out, right? Tan of negative 1 is where we have square root of 2 over 2, square root of 2 over 2. So maybe you could have figured that one out just by looking at the unit circle. Alright, so your polar coordinate is 2 square root of 2 and 7 pi over 4. Alright, example 9, they're giving us x and y, and we've got to come up with r and theta. So we're going to do x squared. What do I get when I square negative 2 square root of 3? 4 times 3, which is 12. Y'all get that? Negative 2 squared root of 3 squared is 12. 2 squared is 4. So x squared plus y squared would be 12 plus 4. That's equal to your radius squared. So radius squared would be equal to 16, and your radius would be equal to 4. Now let's set up our tangent. Our tangent is our y divided by our x. So tangent equals 2 divided by negative 2 square root of 3. The 2's are going to cancel, and you'll have to rationalize, and you'll end up with negative square root of 3 over 3. You'll end up with 1 over the square root of 3. Then you'll have to rationalize. You have a positive divided by negative, so that's negative square root of 3 over 3. So go back to your rectangular point. If x is negative and y is positive, what quadrant are we in? Second. So let's use the unit circle on this one. Where is tangent negative square root? What angle in the second quadrant gives me a tangent value of negative square root of 3 over 3? What angle on the unit circle gives me a tangent value of negative square root of 3 over 3 in the second quadrant?
5 pi over 6.
5 pi over 6. So your polar point is 4 comma 5 pi over 6. Alright, we're going to skip number 10 because we're running out of time. Number 11 I think you can do without any work because 0 comma negative 6 is on an axis. So if you think about where that is located, 0 comma negative 6 would be located down here. So can y'all get me a polar point that gets to that same spot? What would my radius need to be? 6, and then I would rotate counterclockwise how many radians? Positive 3 pi over 2. So anytime you have a point that's on an axis, you probably can do those without any work. Everything else, you'll have to do the x squared plus y squared equals r squared. You'll have to do tangent. It's the angle that's the hardest to get. So you're really going to have to make sure that you practice this and see if you have any questions. All right, the last couple examples, I think I came up with some new equations and I ran out of room. I wrote it all the way up the side of your notes. So these are already worked out. I thought I would run out of time. So if y'all will just kind of watch me work through the problems, they're already worked out for you. So your last set of directions for your homework are going to say convert each rectangular equation to a polar equation that expresses r in terms of theta. And I've written, remember that x is equal to r cosine theta and y is equal to r sine of theta. So on example 12, they're going to give me an equation that has x's and y's in it. That's called rectangular form. In the place of the x, I'm going to substitute in r cosine theta. And in place of the y, I'm going to substitute in r sine of theta equals 5. And then the directions say express your equation in terms of r. That means solve for r. So if you all notice, both of these terms have an r. So I can factor out an r. And then we're solving all of our polar equations. We're solving them all for r. So then that's why I divided both sides by cosine plus sine. So this same equation in polar form is r is equal to 5 over cosine times, or cosine plus sine. So basically, most of these problems, what you do is you just start out by substituting r cosine theta in for x and r sine theta in for y, and then solving for r. 13 is a little bit more difficult. So again, I've worked it out for you if you'll just watch me do this one. So this time you have an x squared and a y squared. That's just going to make you have a little bit more algebra to do. So you're going to have, in the place of x, you're going to have r cosine theta squared plus r sine of theta goes in for y squared equals 3. When you square r cosine theta, the r gets squared and so does the cosine. Same thing with r sine of theta. When you square that, you get r squared times sine squared. Then we are solving for r, and I have two r's, and they're in both of those terms are 2r squared, so you can factor out an r squared, and what will you be left with? Cosine squared plus sine squared, which ought to ring a bell for you. That's one of our Pythagorean identities. And what can I replace cosine squared plus sine squared with?
1.
I can replace that with a 1. So then I have r squared is equal to 3. Almost solved for r. Now I just have to take the square root of both sides, and I technically get a plus or a minus here, but they just want you to leave it as a positive. They're thinking that the radius of your equation is going to be positive, and then that would be your answer. Alright, this is different, so you're going to have to practice it. It's not necessarily difficult, but it is different, something that you haven't done before.